Welcome to the Explainer. Let's jump right into this because today we are taking an epic architectural tour through the geological bones and diverse landscapes of the Indian subcontinent. When we look at a map, we usually just see the surface, right? The rivers, the mountains, the deserts. But underneath all of that is this incredibly deep, ancient history of violent collisions, shifting tectonic plates, and patient, relentless erosion. So we're going to peel back the layers today and see exactly how this massive landmass was built from the ground up, literally shaping the lives and cultures of over 1 billion people. So here is our roadmap for today. To understand the surface, we've first got to look at India's deep geological bones. Then we'll tour the 5 physiographic rooms built right on top of them: the young northern mountains, the great river plains, the ancient Peninsular Plateau, the desert and coastal plains, and finally, the remote island groups. All right, let's kick things off with Section 1, India's deep geological bones. Because honestly, the whole subcontinent is essentially a massive story of competing geological forces. Picture 2 completely opposite geological personalities going head-to-head to create the foundational tension of the entire landmass. On one side, down south, you have the Peninsular Block. This is the Old Guard. It's made essentially of these highly ancient gneisses and granites. And since the Cambrian period, this block has stood remarkably rigid and stable. It literally does not budge. On the other side, up north, you've got the Himalayas. These guys are the unruly newcomers, young, weak, and super flexible in their structure. They are tectonic in origin, which means they are constantly getting pushed and pulled by internal and external forces, creating all sorts of faults and folds. So you have the ancient, unchanging bedrock of the south slamming right up against the dynamic, actively shifting young mountains of the north.
And what happens when an immovable object meets an unstoppable force? You get a massive gap in between them. Originally, this was a colossal geosynclinal depression that peaked around 64 million years ago. But over millions of years, the rivers flowing down from those young mountains and up from the rigid peninsula acted like a giant conveyor belt. They slowly filled this crater with alluvial deposits. Today, that sediment is astonishingly deep. We're talking 1,000 to 2,000 meters thick. This totally filled-in depression acts as the third foundational pillar of the subcontinent. Moving right along to Section 2, the young northern mountains. Let's anchor ourselves at the very top of the map to check out the first of our major surface regions. The Great Himalayan Range is an absolute beast of a barrier. It stretches a staggering 2,500 kilometers from east to west, and its width varies from 160 to 400 kilometers. But remember, these mountains are young and highly active. Because of that, they are violently being carved up by incredibly fast-flowing rivers that are still in their youthful geological stage. This means the water up here isn't just calmly bubbling along. It is violently ripping through the landscape, leaving behind these dramatic, steep gorges, razor-sharp V-shaped valleys, wild rapids, and towering waterfalls. Now, if we follow all that wild water rushing down from those youthful mountains, we arrive at Section 3. The Great River Plains, which stretch for roughly 3,200 kilometers across the continent. The really crucial thing here is how this water behaves the second it hits the flatlands. It's honestly like watching a magic trick. When the mountain streams first crash onto the slope, they hit the Babar, which is this narrow 8 to 10 kilometer wide belt of heavy rocks and boulders. And the rivers actually just vanish. They disappear right into the rocks. But don't worry, they pop back up just south of there in the Terai Belt. Except here, they surface without any defined riverbeds, creating this massive 10 to 20 kilometer wide, marshy, swampy wonderland that is just bursting with vegetation and diverse wildlife. Finally, flowing further south, the rivers reach the mature alluvial plains, featuring the older Bangar and newer Kadar deposits. Here, the rivers finally chill out, meandering around and creating mature landforms like sandbars and oxbow lakes. This entire natural process is exactly why these plains have such incredibly fertile soils, acting as the agricultural heartland that literally feeds hundreds of millions of people. The sheer scale of this water system is off the charts, and it forces some pretty fascinating geographical behaviors. For example, the states of Haryana and Delhi actually act as a massive natural water divide between the Indus and the Ganga river systems. Meanwhile, you've got the powerful Brahmaputra River flowing in from the northeast. But right at Dhupri, it takes this sharp, almost perfect 90-degree turn south before entering Bangladesh. Ultimately, the mouths of all these dynamic rivers fan out to create some of the largest deltas on the entire planet, including the world-famous Sundarbans. All right, let's pull our focus sharply south for Section 4, the ancient Peninsular Plateau.
This vast, irregular triangle of land rises anywhere from 150 to 900 meters above those river plains we just toured. This is the oldest, most rock-solid part of India, and it's broken down into three main subregions. Down south, you have the famous Deccan Plateau. Sitting right above it are the Central Highlands, which are packed with these highly worn-down relict mountains like the Sapura Range and fascinating metamorphic rocks like marble and slate. Finally, there's the Northeastern Plateau. Now, if you want a cool trick to understand this entire massive block, it generally slopes downward from the west to the east. How do we know that? Because it totally dictates the eastward flow of the major rivers right into the Bay of Bengal. Now, bordering that Deccan Plateau are two totally distinct mountain ranges. Comparing them is basically a masterclass in how erosion shapes a continent over deep time. On the west side, you have the Western Ghats, this imposing continuous wall averaging 1,500 meters high. It's home to the Anamudi Peak, which towers at 2,695 meters, and it's the birthplace for most peninsular livers. The Eastern Ghats, on the other hand, completely different story. They are lower in elevation and super broken up. They are discontinuous simply because they've been absolutely battered and eroded over millions of years by powerful eastward-flowing rivers like the Mahanadi and Godavari, cutting right through them. But eventually, these two very different borders do meet up down south at the Nilgiri Hills. If we look way over to the northeast, specifically the Meghalaya and Karbi Anglong region, things get really interesting. This is actually a detached piece of the peninsular block, separated by a massive geological fracture called the Malda Fault. Underground, this northeastern plateau is an absolute gold mine. Well, a coal, iron ore, and uranium mine, to be precise. It is incredibly wealthy. But up on the surface, it takes an absolute beating. Because it catches the maximum impact of the southwest monsoon, its surface is severely eroded. Places like Cherrapunji are famously reduced to just bare rocky surfaces, totally devoid of permanent vegetation, simply because the torrential rains have washed all the soil away. Let's zoom out to the outer edges of the subcontinent now for Section 5, the desert and coastal plains. Up in the northwest, just past the Aravalli Hills, lies the Great Indian Desert, an area often called Murastali, which translates literally to dead land, and it totally earns that name. This is a harsh, rolling landscape of sand dunes that receives less than 150 millimeters of rain a year. It's a severe water deficit region. In fact, most of the rivers here are ephemeral. Some streams, like the Luni, just flow for a bit and then literally disappear into the sand, or they pool up into brackish lakes and playas. And these natural salt flats aren't just geological curiosities. Locals have actually relied on them to harvest salt for generations. But here is a massive surprise for you to take away from this explainer. Look at this number, 180 million. During the Mesozoic era, roughly 180 million years ago, this completely bone-dry, water-starved desert was actually sitting at the bottom of the sea. No way, right? But geologists have proven it for a fact by discovering rich marine deposits and 180 million-year-old wood fossils at places like the Akakal Wood Fossil Park. It just goes to show the Earth is always rewriting its own map. Leaving the desert behind, let's trace the coastlines. And when you look closely, there is a night and day difference between India's two flanks. The western coastal plain is submerged. Because the land drops off so steeply into the water, it's narrow, but it provides remarkably deep natural conditions for great ports like Kandla and Cochin. That deep water access is a total game changer for modern global maritime trade. But over on the east? The eastern coastal plain is emergent. It's much broader and completely dominated by the sprawling deltas of those east-flowing rivers we talked about earlier. And because the continental shelf stretches out up to 500 kilometers into the sea here, the water is just way too shallow to support many natural ports. Now, a super unique feature you'll find on that western shoreline, specifically along the Malabar coast in Kerala, are the kales. These are incredibly intricate networks of backwaters. But they aren't just pretty geological quirks to look at. They are deeply integrated into the local way of life, serving as the absolute lifeblood for fishing, inland navigation, and yeah, they are a massive draw for tourism too. Finally, let's hop off the mainland entirely for Section 6, India's remote island groups. We've got two major, totally different island systems hanging out in the surrounding seas. Over on the eastern side, in the Bay of Bengal, we have the Andaman and Nicobar chain. This is a massive cluster of about 572 islands and islets. And get this, Geologically speaking, these aren't just random sandbars. It's believed they are actually the elevated peaks of submarine mountains poking right up out of the ocean floor. Separated by the 10-degree channel, it's a wild, mountainous region featuring peaks like Saddle Peak hitting 738 meters. Oh, and it's highly geologically active. In fact, it's home to Barren Island, which holds the title of India's one and only active volcano.
Now compare that wild volcanic mountain chain to the Arabian Sea Islands off the western coast, Lakshadweep and Minicoy. These are built completely differently. Instead of volcanic mountains, they are entirely flat formations, built completely from coral deposits sitting 280 to 480 kilometers off the Kerala coast. There are only 36 islands here in total, and humans only live on 11 of them, with Minicoy being the largest. And because they're out there taking a beating from the ocean, their eastern seaboards are famous for these rugged storm beaches, made up of loose pebbles and boulders.
And just to quickly clarify a geographical term you'll hear a lot when exploring these regions, like in the Ritchie's Archipelago in the Bay of Bengal, we have islets. When we say islet, we literally just mean a tiny, often unnamed rocky outcropping. They barely have any vegetation, and there's absolutely no way a human could live on one. Think of them as the tiny little punctuation marks at the end of India's sprawling geographical sentence.
And that wraps up our architectural tour of the subcontinent. We've seen how rigid, ancient bedrock goes toe-to-toe with youthful mountains, we've watched rivers literally sculpt the plains, and we've explored coastlines and islands born from fire and coral. But here's the biggest takeaway. This architecture is not finished. The Indian plate is still ramming into Eurasia. Rivers are still slicing through the Himalayas. The wind is still shifting the sands of Marastali right this second, which leaves us with one pretty mind-bending question to ponder. With the Earth's engines still running at full throttle, what is the subcontinent's architecture going to look like a million years from now? Thanks so much for joining me on this explainer. Keep wondering, and I'll catch you on the next one.